I built a Bytepusher VM in Flutter. You can kind of think of Bytepusher as a minimalist virtual machine. It's a simplified version of the Chip 8, which is also a virtual machine, pretty minimal too. And that was the predecessor to the Pico 8, and we could keep going and going and going. But the idea here is if you've ever used an emulator before, it is essentially a form of an emulator. So let's talk a little bit about it and look at some code. This is the documentation on what Bytepusher is, so you can learn more about it here. The part that's really interesting, it's a barebone hardware abstraction layer that provides only memory map, pixel, and audio sample buffers, key states, and a fixed frame rate. All the high-level stuff has to be done in software, which means that our VM is really only this. And then the ROMs, the files that are loaded into memory, have to take care of all of this. You can kind of see the features, what it's intended for. In my opinion, education is the big one here. This is probably one of the easiest virtual machines that you can make. The specifications are listed right here as well, so you can see the frame rate, the CPU speed, all of this. It's relevant if you're going to build your own, but we can talk about kind of what mine looks like here in just a moment. Colors, how you determine color values. This is kind of important. The Bytepusher does support a keyboard, but it uses the same hex layout keyboard as the Chip 8, which means you only have 16 keys that you're working with. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A, B, C, D, E, F. Those are the only ones you have to support. Here's some information about memory mapping. Like if you want to build your own, you should definitely read this and understand it. And then there is an outer loop and an inner loop. And this is basically the specification for Bytepusher. One nice thing about Bytepusher in particular, they have all these test programs that you can download. I've downloaded a bunch of them. And then your program should be able to run these. That's kind of how that works. And then you can find other examples and source code to look at if you're stuck, or if you just want to peruse some Bytepusher VMs. It's pretty cool. So this is mine in Flutter. I hand roll the VM down here. So this is mine in Flutter. I hand roll the keyboard down here. So I don't take input from like a device keyboard because my plan was to put this on mobile apps and desktop and all sorts of other things. So there's an insert ROM button here. So you can hit insert ROM. You get some files. I'm going to upload the keyboard test. So if we hit this, we can see that it's rendering to our screen. And then when we press 6 lights up. So this is a simple Bytepusher program. This is kind of neat, but where it becomes really cool is if you swap out the ROM and insert something else. So in my case, I'm going to insert the sprites ROM, and you can see now we have the Bytepusher sprite ROM running in our actual application. So how does this work? So there's really not too much to it. There's a little bit more than like a C++ implementation. Those generally are around 100 lines, maybe a little bit more. And a lot of this is Flutter. So we do have two dependencies that I had to pull in. I'm going to go ahead and stop that. So the first dependency is the file picker, just to help with picking files, and then just audio, so we can actually play the audio bytes from memory. The main method looks really straightforward. Nothing going on there. My app should be renamed, but whatever, here we are. I give it a title. I set that blue box decoration just to have some color for our testing. And then I have a frame and a virtual machine. The frame is everything you saw. So that is the this child right here gets passed into the frame. And that's the virtual machine. So that's what you're actually seeing render everything. And we'll talk about a custom painter that actually makes that happen here in a moment. And then we have some columns that this is the load ROM button, and then here's all these keyboard buttons. These are custom to my Flutter project. They take in an address and a label, and then they set memory values based on at that address based on whether the key is up or down. And then technically you can cancel a key press in Flutter. So if you were to push something down and then like slide away from it, you cancel it. So that would also be another case where we need to reset the value to 0. Give them a little bit of a box decoration, center the label, give them a width and height. Okay, so that's the frame. So the VM is where all the fun stuff starts to happen. So in the VM, we have a timer, and I'm shooting for 60 FPS. So we have our FPS hard-coded right there. We run this timer periodically. I have a video buffer, so we have a 256 by 256 grid, and then this is the color of the pixel value that is at that point. Right now they're all set to black, 0, 0, 0. And one interesting thing you'll notice, I am pulling in Flutter material here, but my goal was to make these things, or make the logic here as agnostic to Flutter as possible. So like this could be color.black, but instead passing these values around felt a little more true to a Dart-based implementation, and then using Flutter for just as little as possible. Okay, so we have our timer. I have this VBS, which is not Vacation Bible School, but it's a video buffer screen. This will get added, this will replace our video buffer here later down the road, but we basically black out all of our pixels every frame. And it's worth mentioning, this is the outer loop for us. So if we refer to the documentation here, there is this outer loop. And then this is that outer loop. So we check to see if anything is loaded into memory. If not, we don't really need to do all these operations. In fact, we're playing bytes that probably don't need to be played. So let's refactor that really quick. And we can put that at the end of this if, because if we don't have anything in memory, we have no bytes to play. Okay, so we check to see if memory is loaded. I say memory merge key ops into memory. So this is whenever you press one of those keys, it sets your key memory, and then we need to merge that into 2 different memory slots. So we have memory address 0, memory address 1. So we take the key memory and we do some bitwise operations to map those to our memory values. We get a program counter. Right here, there's a fetch 3-byte program counter. I found the memory management to be a little messy, so I tried to encapsulate all of that into this memory.dart class. So you can see here, there's our memory. Here's our key memory. There's that isLoaded helper. The ability to clear out all of our memory. Load something into memory. Set a specific value in memory. And then these little helpers that are based off the instructions that are captured here. So like fetch the 3-byte program counter. That is this. Copy 1 byte from A to B. I don't see that directly in the list here, but something else that we needed to do. And then we needed to jump the pointer to the next one. Okay, so with that in mind, we get our program counter. We follow our instructions here and iterate from 0 to 65,536. And for each of these iterations, we copy a byte and then we jump the pointer. This is what's like actually changing the memory that we're running and the memory that's being processed. So that's how we're getting interactive things. Like the example that we had with the sprite that was rendering and twirling around, like that's the interactivity that we're getting. Now I need to generate this 256 by 256 video buffer, right? So now what I can do is I can use this helper to get the pixel color address at a given piece of memory. So I have X and Y. So for the screen 0, 0, for example, X would be 0, Y would be 0. We map these right here. Once we get that, we convert these to colors. So we can get the blue, the green, and the red following the instructions that are captured here. I don't remember where in the documentation they're captured, but they are captured here. And then finally, I set the X and Y to that color. We play bytes if there are bytes in the memory address for audio, which you can see is right here. And then we set state, and we set our video buffer equal to our video buffer, our local video buffer. Okay, there's a lot going on in that timer. The actual layout here is fairly straightforward. I use a layout builder that allows me to shrink or grow the application or handle multiple device sizes, however you want to phrase that, I guess. I was mostly doing desktop work, so I was constantly resizing the application. And then I have a custom painter, and we'll change that to true. I probably should optimize this a little bit more. This is hinting that this should probably change. I don't think this should always be set to true. It's something I should look at. So if we look at this custom painter, sorry, that's provided by Flutter. If we look at my custom painter, the Bytepusher painter, it takes in a video buffer. So this is a 256 by 256 grid of pixels to paint. And then it's actually really straightforward. You can see we have our dimensions here. We have a paint method. We iterate through those and we paint them. That's it. There's this draw pixel method that I wrote. This looks at the size of the canvas. So if we do scale up, I can multiply the X and Y that we're painting at and the width factor and height factor. Handle a width factor and height factor for the width and height of the pixels that we're painting. That way it's always 256 by 256, regardless of the actual size of the canvas. This should repaint. Again, this is something I probably should optimize a little bit more. Okay, I think we've almost covered everything. That's kind of simple, and one of the benefits of this is it's really straightforward, kind of once you understand it. There's also a byte stream here. This extends the stream audio source. This is a just audio thing. I basically need to get a list of bytes and pipe them into a audio driver and let them play. And trying to figure out how to do that in Flutter, this was probably the cleanest way that I found. So I created an audio engine class that has a player, and then I have this play bytes, and it sets the audio source equal to this byte stream class right here. So an instance of the byte stream class, and the bytes that I'm passing into it, and then triggers play. So it'll play the sound. I think that covers just about everything. We've walked through memory, main, keyboard, frame, Bytepusher painter, the virtual machine, and the audio engine. So that's about it. One thing that's cool about this in Flutter is it runs on iOS and Android, Windows, Mac, Linux, web. It is a little slow on web. I need to see if I can figure out how to fix that. There are JavaScript implementations that work great on web of Bytepusher. I think this is just the unfortunate reality of running Flutter web, and then also having some pretty complex logic that doesn't single thread very well. But I could be wrong, so I need to do some more research into that and figure out what's going on. Anyways, this is Bytepusher. Hopefully this was cool. If you want to learn more about Bytepusher, you can go to esolangs.org, esolangs, as in esoteric, and then search for Bytepusher. Or you can go to github.com/BradSeipert/Bytepusher Emulator and find the emulator source code yourself. This is a color test. I didn't load this one up into memory, but this is just a really great test to make sure that your Bytepusher virtual machine works as expected, because it just renders colors. It's nice and easy. Yeah. Also, there are no ROMs in this repository, so if you want a Bytepusher ROM to run, you need to go find one. So esolangs.org/wiki/Bytepusher has several Bytepusher programs that you can load up into memory. You also might be able to find some other ones out there on the internet. So yeah, have fun with it. Try to build your own. I had a really great time, and it only took a couple hours. And honestly, if it wasn't for some weird Flutter intricacies, it probably wouldn't have taken that long. But I am happy that I ended up using Flutter in the grand scheme of things. Thanks. Have a great day.